The web is a contender. What a great provocative title for a JavaScript conference. I trust you're all members in the church of Tim Berners-Lee, so I'm kind of preaching to the choir. Anyways, who's this guy talking on stage? This is me. I'm Surma. I work with the Chrome team for Google in London, and I do webby stuff, which I enjoy a lot. And I'm kind of here to talk about new things that are coming up on the web, and some of them are actually already there. And the first thing I want to show to you is the home screen experience. That's something that actually is not on the web, really, because it's something, if you're on the home screen or you have an icon on the home screen, you kind of expect the app to open up and do its job, even if you're offline. So I went into airplane mode, and I can still record my voice memo, save it to disk, or to the phone, rather. If I wanted to, I could even actually kill the app and reopen it, and everything would still be there. All the state is there, all my data is there. This is kind of what we expect when something is on the home screen. And this is also something that so far wasn't really possible on the web. This, however, actually is a web app. It's a web app a colleague of mine wrote. It's written by Paul Lewis. So some of you may have known the app or may have known that this is possible. But I want to get everyone on the same level and also clear up a few misconceptions about the current state, what is possible and what is not. So let's start with a few numbers first. When you look at Chrome, and I really mean Chrome alone, Chrome has over 1 billion users right now. That is a lot. And just as a side note, 25 million of these 1 billion users open DevTools every week. So not only do you have this huge amount of users, you also apparently have a huge developer user base who try to go through the same experience as you do, and you should probably try to connect with them. As I said, that was Chrome alone. So if you add up all the popular browsers and also add in a few unpopular browsers, you actually end up with a huge number of people who are working on the web. As you can see here, this is a Nintendo DS. There's no public SDK. There's usually no way for you as an indie developer to really publish something there, but they do give you a web browser. So suddenly, you actually have a way to do something on this device. And with all these possibilities for people to go onto the web, you actually find that the biggest strength is reach. The web is everywhere. It's on phones, it's on computers, it's on Nintendo DSs, it's in cars, even the ones without Android Auto. So for the user, really, it is the most generic platform. And if you know something is on the web, you will pretty surely find a way to access that thing one way or the other. And with all these possibilities, you actually end up with the most impressive number. And that is that the average user actually ends up using over 100 websites a month. And I'm not talking iframes and ads and redirects. I've been assured by statisticians that this is a legit number, so I hope they're right. But compare that to the corresponding native number, which is that the average user uses about between 12 and 20 native apps per month. So there's a huge difference. And another strength of the web actually is that jumping to 7 different apps in a matter of seconds is completely normal. Try to imagine that experience in the native format. And then recently, a kind of older article by VentureBeat resurfaced and got a lot of attention. And the headline read this: "The mobile war's over, and the app has won." And I was like, what? So this is such a weird thing to say to me, because first of all, for the first time, I feel like the web can actually compete in terms of performance, technology, features with the things that native already have. And secondly, did you hear the numbers I just said? Like, how can they possibly justify making that statement? And of course, in the article, they do justify it, and it's this: the time you spend in native apps takes up to 80% of your total time spent on a mobile device. So web is dead, right? We're done. Then again, once again, you take a closer look, and you kind of realize it's not that simple. Because of these 80%, 32% is for gaming, 18% is for Facebook alone, and 8% is entertainment. And obviously, these are all categories that are really time-intensive. Like, for example, entertainment obviously has something like Netflix, an app that is open for 40 minutes, an episode of a series, but you don't interact with it really. You have games, which you obviously do interact with, and games is something that the web obviously cannot really compete with in the long run. But then again, if you like remove these, let's just call them special like corner cases, right? If you remove them, the landscape actually kind of gets different, and it's kind of a 50-50 thing between the web and native. And also very important, the stats that these graphs are based on are actually based on data from April 2013. So a lot of things have changed on the web since then. So these numbers might have shifted. And if they have not, the things that I'm going to talk about, hopefully and pretty surely will. So yeah, let's talk about these things that's going to change. But before that, Peter Paul Koch suggested a short while ago a one-year moratorium idea for the web. He was basically saying that the web is moving too fast and the browsers can't catch up, and we should just stop for an entire year and give the browsers a chance to catch up. And there was a whole discussion. It was blowing up, and John Gruber, the inventor of Markdown and blogger on Fireball, actually wrote a counter or an answer to that. And I don't agree with everything he said, but he said this. He said, native apps can't out-web the web. And I think that is completely true. Because even though native and web seem like very similar, they have very different fundamental assumptions at their core. So we should not try to just nail every feature that native has onto the web, at least not, and especially not in the same way. That's just something to keep in mind. And an example for this would be, does every website get access to my webcam? On both native and web, you would say, well, of course not. So you'd probably ask for permission just in time, or for native, you can actually do this batch grant thing at install time, right? Does every website get background sync? Probably not, but also, do you want to bug your user about it every time you want to do background sync? Also not really, right? So we don't have really an installation dialog on the web for batch granting. We also don't have a central authority to check if the things that the app is doing are actually sane. Everybody can publish on the web. So you see how this is like a really big UI and UX challenge for the browser vendors to face, because they want to make it secure for the users, but also give you, the developers, as much capabilities as possible. So just to make the app metaphor work even better on the web, just think about it this way. Your phone has all the apps installed. And once you open them, they actually get installed on the, like downloaded on the fly. This is kind of how you can think about web apps. But the thing is, right now, we don't expect web apps to really work offline, to not have an address bar, or even to be on your home screen. And these are the things that I want to address today. So let's start with the fact that web apps are usually hard to reach, because you have to type in a URL on your tiny, tiny keyboard, on your tiny, tiny phone, or you have a big one. You can add them to your home screen. You actually could have done that for a long time now. But the feature is, as you can see here, hidden in kind of like hidden in the menu, and therefore it is hardly used. And that is something that needs to change. And what has been proposed is app install banners. Basically, if your user fulfills certain criteria, and right now it is he uses your web app twice in a time frame of 2 weeks, this banner will be proposed to him, and he can, with one click, move it to his home screen, and suddenly you have combined the reach of the web with like this stickiness of native apps, because it's now on your home screen. On your side, you have to fulfill a few criteria as well, because you do have to have a manifest, a web app manifest. This looks something like that. So you have a name, you have an icon, you have a color, you have an entry URL. In this case, I also added a query part to the entry URL, so I can track if people would actually be using this. And the app icon, which I defined in the icon array, would now be on my home screen, indistinguishable really from the native apps. So since, as I said in the beginning, that comes with certain expectations from the user, you have to have HTTPS and a service worker that the banner is shown in the first place. So this is kind of a way for us to incentivize keeping the whole home screen expectation thing a solid thing. Also, by the way, just as a side remark, you can delay the prompt, but there's no way for you to prompt earlier for it. This is just something, otherwise spam sites will just pop it over and over on you, and it will just be annoying, right? So that's something to keep in mind. So let's talk about Service Worker. I've mentioned them twice, and some of you may not know what they're about. Service Worker are kind of a silver bullet. By themselves, they don't really address any shortcomings that we have versus native. So they, however, give us, the way that they work, give us a common entry point or even some kind of API to all the apps. So they're really a new concept in the framework of web apps. So what they are really is just a background process, a JavaScript background process that is decoupled from your app's main thread. It is actually running separately. However, it is connected to every instance of your app. That you can think of that to every tab that is currently open that is part of your app. They are a background process, but they're not really long-running. They're more available, and they're bound to lifecycle events, foreground events, and background events. So there's some kind of event-based communication going on, but you don't do like long-running work, really. Also, the cool thing about this concept is that they're progressive enhancement. So if the browser doesn't support Service Worker, everything will work as before. But if the browser does support them, a whole new extended experience is offered to the user. A colleague of mine, Jake Archibald, actually wrote this website, which is called Is Service Worker Ready? Service Worker come with a lot of APIs, and obviously I'm only going to be able to cover a few of these in this talk. But he has basically a listing of all these Service Worker-specific APIs. He has short tests for them to test, so you can see if your browser supports this particular feature, and a little bit of demo code so you can see how to use it, and links to the official spec, obviously. So let's start using Service Worker. It's actually kind of simple. So the first thing that I do is I do feature detection. I check if the navigator object actually has an attribute called Service Worker. And if it does, I can be pretty sure that Service Worker are supported. I then call register with a link to a file. And that will be downloaded and executed inside the Service Worker. That returns a promise. And once installation has been completed, and completed successfully, this promise will resolve. This Service Worker will be scoped to your current website and the current path. You can make the path narrower, so you're scoping yourself to an even longer path, but you can't go upwards. This is just kind of a security feature. So now we have a Service Worker running. What do we do next? Well, the first and probably the most impressive feature of Service Worker is that they are kind of a network proxy for all of the requests that your site is doing. So this lets you do like very sophisticated caching and lets you do very complex offline experiences. Even for the data from other origins, for example, in this graphic, I kind of hinted that the image is hosted on G+ and not by me. You can actually cache the response. Since on another origin, you can't inspect it. It's called an opaque response, so you know there's something in there. You don't know anything about it, but you can put it into a cache. And if it's your own data you're requesting, you can even manipulate the request and the response. So you could do wild stuff like actually do templating in a Service Worker and just have it transparently go through to your main site, or do SAS compilation. Although keep in mind, you should be trying to have the progressive enhancement thing still going on, which in this case would be breaking. So here, for example, I define items, the crucial items that I need for my site to be running offline. I hook up to the install event in my Service Worker. I open up a new cache, which is identified by cache name, which is a string. And once it is open, I just add these items via the cache API. The cache API has add all, which is a convenience function. It just takes an array, and it takes care of both downloading and caching these things. Event.waitUntil is kind of a new thing inside Service Worker. It takes a promise, and then this promise is coupled to the promise in the other thread, the register call. So the register call promise will only be resolved once this thing actually finishes. So this means that once this is open, I already have the important parts of my site cached. The next step would be, you can also do it on demand, of course, hooking up to the fetch event. For each request, this fetch event will be fired. And what I'm doing here is, again, I take my cache, I match the request, and the cache API provides this match function for you already. And if it returns something usable, I'll just return that, and otherwise I'll use the fetch API to actually get the data from wherever. This is a simple cache implementation. My app would start working offline immediately. This obviously is also a very dumb implementation, because once you start caching, you will never look at the network again, and it will grow stale pretty fast. But you can see, I mean, you have JavaScript at your hands. You can do arbitrarily complex stuff here. Again, Jake Archibald wrote a great demo for this, which is an offline Wikipedia. So what he does, he basically gives you a switch at the very top to give the ability to cache the articles in kind of a JSON-style format, so it works offline. And if he kind of detects that the connection is flaky, he uses another API of Service Worker, which is called background sync. So he actually moves the downloading part from the main thread to the Service Worker thread, which enables you as the user to leave the app and keep the download going in the background. So you don't have to stay in the app and just wait for the network to do something. He just does it in the background and pushes a notification onto the screen once the data is actually there, and you can look at the article. You can do uploads as well, by the way. A while ago, Google published the SW Toolbox, which is a toolbox of Service Worker tools, hence the name. It has a lot of caching strategies implemented for you. And also, it has a router implementation, so that the fetch thing that you're going to be doing, you can do this, you can match by patterns and routing. So it's just a little bit of convenience to make it easier to write these complex offline strategies. I said that service workers are available but not long-running. The interesting part about that statement is that they're also available if Chrome is completely closed. So that means you subscribe to events, and the browser knows that it can call these events, or the operating system in terms, if you're in the context of Android, that it can wake up this particular service worker if something comes in regarding or in relation to your app, even though Chrome might have no tab open whatsoever. And this is probably something that's most important, because this enables us to do push notifications. Push notifications are kind of the holy grail of user re-engagement, right? Until now, you had no way of letting the user know that something important has come up on your side of the app, and you just couldn't notify him if he closed your tab. And it's been proven that this significantly increases the engagement of the user, and maybe to our dismay, it's part of every native app nowadays. But we kind of want to have them on the web as well, right? And they're also not that hard to use. So the service worker itself has a push manager attribute. When you call subscribe, you basically get back an endpoint, which in terms, if you're a full-stack developer, you would just put it on your back end and save that URL there, and know that if you push data to that endpoint, it will end up on the user's device. For Chrome, this would obviously be tied for Google Cloud Messaging. For Firefox, it will probably be Mozilla push services. So the only thing you actually need to do is put a little bit of data in your web app manifest so that the browser knows what project you're related to, that it actually hooks up to the right events. Once you got your subscription going on, the only thing you need to do is to subscribe to the push event in the service worker, and this event will be triggered once a push notification, or a push message rather, comes in. This actually works on both Chrome desktop and mobile. And then you can just show notification, put some URL in there in the data, and once the user clicks on the notification click event will be triggered, and you can pull out the data from the notification again and open it in a new window. Or it is also possible for you as the service worker to just list all the open tabs and replace the contents of one with a new one if you think that's appropriate. By the way, the Facebook web app does this already. So if you go to the Facebook web app, put it onto your home screen, you will get notifications from that app, which I think is really cool. Again, there's a little demo online. It's called a push demo. The link is on the bottom right. You can see me subscribing to push notifications, and then I'm actually literally closing all tabs, all of Chrome. And then I'm triggering a push notification from my desktop in the console. And you will see it actually show up in the bar, and I can click it, and it will open up the URL that I embedded, which in this case is the weather of London, which is not that exciting. However, if you think about that, we just got lots of cool features on the web to actually write much broader experiences for your apps. One thing I mentioned but haven't really been clear about is that that you do need HTTPS for Service Worker, and you do need Service Worker for basically all the features I just mentioned. This might come as a letdown at first, but HTTPS should really be used for everything, in my opinion. We all know it's not a reality right now, but we do have services like Cloudflare who offer it for free. So you just put them in front of your static hosting, and suddenly you have HTTPS. Let's Encrypt is due to launch in Q4 this year, so I guess any time now. And they promise HTTPS encryption for your own servers as well, and it's supposed to be just as easy as Cloudflare. So at that point, there really is no excuse anymore. So start doing it now so you won't be surprised at that point. Bottom line is, we just got very important features to make the apps on mobile so much better. And I encourage you to play around with it because it's lots of fun. And Service Worker gives you a whole new mindset when doing web apps because you have this weird ability of intercepting network requests and doing weird things in the responses. And if you have questions, feel free to just hit me up on Twitter or come to me in person. I'll be around for a while. And with that, thank you for your attention.